So we're going to be starting a whole new unit, and that unit is going to focus on perimeter and area of all different types of polygons. Perimeter is old. It's not something that requires really a formula, although you can apply one to certain figures. But if you know the definition of a perimeter of a figure, you can go ahead and apply that to any kind of polygon and any kind of figure that you're given. Our focus mostly is going to be on area, but before we move on to area, let's go ahead and write down the definition of perimeter. And the definition of perimeter is perimeter of any polygon is the sum of the lengths of all of the sides of the polygon. The sum of the lengths of all of the sides of the polygon. And like I said, that's not something that's new, and you can apply that to any polygon that you're given. It's area, however, that needs different formulas. So we're going to break down our area into 3 categories. We're going to break it down into area of a parallelogram, area of triangles and trapezoids, and then area of rhombuses and kites. So let's start with area of a parallelogram. So the area of a parallelogram, given base B, so I'm going to abbreviate, our base is going to be the variable B, and the height is going to be represented by the variable H. The formula is A, which is area, equals BH. Now remember, if there's not a symbol between your 2 variables, that means multiplication. So the area is equal to the base times the height. So let's go ahead and draw a diagram to represent that. Since this is a parallelogram, I'm going to exaggerate the figure a little bit so it's very clear that this is a parallelogram. Okay. We're going to call just the bottom side B. It can be any of those 2 parallel sides at the top or bottom. And we're going to go ahead and call this right here H. Now notice what I'm putting on the H is a 90-degree angle because the height has to be perpendicular to the base. No matter which base you decide to use, the height must be perpendicular to the base. So I could actually go ahead and put my height out here as well, because if you guys remember, the height has to be perpendicular to the base, to a line containing the base. So I can use that red line right there also as the height, because as you know, the height's not always going to be given inside of your figure. So that's the formula for the area of a parallelogram. Let's now move into area of triangles and trapezoids. We're going to be using the same variable B and H, B to represent the base and H to represent the height. So for a triangle, let's go ahead and draw a triangular figure. And again, we're going to go ahead and label that bottom side B. It does not have to be the bottom, but you do have to make sure that whatever height you have must be perpendicular to the base. Just like that. And so the formula for that is area equals 1/2 base times height. For a trapezoid, let's go ahead and separate those 2. For a trapezoid, let's draw a figure that looks like this. I'm drawing them a little bit more exaggerated from what you normally will see, just because it's going to allow you to make that connection. We're going to call the top base 1. We're going to call the bottom base 2. Again, it doesn't have to be top and bottom. That's just what I'm using. And then again, the height has to be from base to base and perpendicular. And the formula for the area of a trapezoid is area is equal to base 1 plus base 2 in parentheses times height. So first I have to add the bases, multiply by height, and then divide by 2. So that's the area of triangles and trapezoids. Now you want to come down on your paper and we're going to do the area of rhombuses and kites. Now the cool thing about the formula for area of rhombuses and kites is if you remember on that quadrilateral chart, they fall under 2 totally different categories. However, the formulas are actually the same. However, we're not going to use B and H anymore. We're going to use 2 different variables, and those variables are A still for area, but we have D1 and D2. And these both represent diagonals. And if you guys remember, diagonals go from one vertex to the next non-consecutive vertex. And this formula, A equals 1/2 D1 times D2, can actually be applied to any quadrilateral with perpendicular diagonals. Okay, so if you come across any quadrilateral with perpendicular diagonals, you can use this formula. I'm going to just quickly draw a sketch of a rhombus and of a kite and label the diagonals so that way you know what that's going to look like. If we remember, in a rhombus, we have 4 congruent sides, although not necessarily congruent angles. And so my diagonal would be, there's one right here. And one right here. And even though my diagram doesn't look like it, these are going to make sure that they are perpendicular. So we're going to call one of them D1. We're going to call the other one D2. That's in a rhombus. And then in a kite, I'm going to make it pretty dramatic. And then same thing. That's one diagonal. That's another diagonal. They are perpendicular. So I'm going to call one of them D1 for diagonal 1 and the other one D2 for diagonal 2. And those are the notes and those are the different formulas. The next video is going to have some examples.